STD expected. A phrase I have never said before and probably never will again. In fact, I might break my rule and say standard instead of STD today. So C++23 has finally introduced something that I think is actually a strong way of dealing with errors properly in C++. Now we're going to spend the rest of this video talking about this, but before we do, let me just cut to the chase and show you what it is. Say for example, you have a function that needs to divide two integers. There's a possibility that that second integer could be 0, and if it is, that's an error. What expected allows you to do is return two possible results, either the actual result if the function succeeds, or an error result. So you can see here that we take in two integers, a and b, but if b is 0, we instead return an unexpected result, which is going to be of this type. Otherwise, we do the division and we return the result of that as an integer. The caller receives this expected object and can check whether or not it's valid. That is to say, whether or not we actually have the result because it succeeded, or we get the unexpected result. If it is valid, then we can use it however we like, such as printing it in this case. But if it's not valid, then we can retrieve the error, which in this case is a string, and do what we will with it. So for this example, I'm trying to divide 10 by 2. If I run this code, then as you might expect, we print result equals 5 because that's what we're doing over here. However, if I change this to be 0, which is invalid, then instead we're getting a divide by 0 error, which is what we set our unexpected object to. So in a nutshell, that is what expected is. It allows you to either return one value or another based on whatever conditions you define. The way this works internally is very important because, of course, we care about what our code is actually doing and performance. So internally, an expected object is actually a union of either the success value or the unexpected value, plus one additional byte, which basically dictates whether or not it's this value or that value. That's it. So depending, of course, on what types you actually put into these template arguments, the expected class itself does not allocate any memory and it stores its data very, very simply, which basically means that the overhead for this should be almost 0. And that's important because in my opinion, that actually makes this quite useful. And that's what we're going to talk about for the rest of this video. Now, if you are just getting into programming and you want a really fun and engaging way to learn, then BootDev, the sponsor of this video, is the perfect thing for you. BootDev takes inspiration from modern game design to teach programming in a super fun and engaging way. They specifically focus on back-end development, but these concepts apply to any language and any type of development. The most important thing when learning programming is that you actually practice, that you actually write code. If you're just watching videos or learning theory without practice, then you're not really learning. BootDev actually has you writing code from the very beginning and in a super fun and engaging way. You'll earn XP, complete quests, level up, talk to your bear mentor who wants salmon as payment, all while writing code yourself, fixing bugs, and really just being a real developer. Now, this bear mentor is an AI chatbot specifically trained on their course materials. So if you get stuck or you want a deeper explanation of something, then you can always have a chat with it. But check this out. All of their content is completely free to read and watch in guest mode. So you can always check it out first. You'll need a paid membership to access the interactive features like hands-on programming. There's lots more to discover, so head to boot.dev, link will be in the description below, and check it out for yourselves. You can also use code Cherno to get 25% off your entire first year if you choose the annual plan. Huge thank you to BootDev for sponsoring this video. Okay, so let's kind of go back to the beginning and talk about this in much more detail. So first and foremost, you need to make sure that you are on C++23. So in Visual Studio, for example, you would go to your project properties, make sure you're in all configurations, and then under C++ and language, you need to make sure that you are, I think I updated Visual Studio like during June 2025 or something. This is still marked as preview, but you can see we have C++23 preview here. Just make sure you are using either C++23 preview, or it's also possible if you're on an older version of Visual Studio, but not too old, you might have to select preview features from latest C++ working draft. But anyway, I recommend you update Visual Studio and you just select C++23 here. If you're using any other IDE or something like CMake or Premake, you can also set the same setting there, but you just need to make sure that you are on C++23 because this is a C++23 feature. As is the printline function, which we discussed in the last C++ video, which I will leave linked up there. So once we are sure that we are in fact using C++23, let's go ahead and include expected. So what I'm going to do here is I'm just going to implement this divide function that we just wrote. So we're going to divide A by B. Usually you'd write something like this. We of course have the risk of actually dividing by 0 here. Let's say we want to handle that error. That's reasonable. And by the way, yes, this function is a little bit silly. No one really most of the time writes functions like this. this, but this is a metaphor. This is supposed to represent a real function in a very simple way, because we're not focusing on the function itself, we're focusing on this kind of error code flow functionality. So without something like expected, how would we handle the case of dividing by 0? Well, I think that probably most people would do something like throw an exception. Now, I'm not the biggest fan of exceptions. They're definitely fine to use. In fact, I haven't made a single video about them. That's how you know I'm not the biggest fan of them. Objectively, they are not that bad. However, from a code flow point of view, I still am not the biggest fan of them, because once you throw an exception over here, you then obviously need to do a try catch block, and it just becomes very messy. Okay, so let's just say we don't want to use exceptions. What other options do we have? Well, instead of returning an int here, we might instead return some kind of like status code. And then maybe the result would be like, you know, some kind of output parameter here that we would set. And then this status, which I'm trying to write as fast as possible, could be something like, I don't know, success, divide by 0. This at least gives you like some context as to what goes wrong compared to if we had just returned a Boolean, but obviously returning a Boolean is also fine. In fact, I probably should have started with that. But anyway, so divide by 0, we can just say not do the division, obviously, and return status divide by 0. I guess error makes sense. Another way to deal with this may have been to actually make something like error and then have this be none. This probably makes more sense. And then divide by 0. And there you go. You have to return either error none or error divide by 0. Then from the calling code, this becomes a little bit annoying. So we have our result from the division of, let's just say 10 by 2. You can see, hang on a minute, that's not the result, that's the error status. The result is actually something that we have to store up here, which I already don't like. And then we have to check if error status equals none, hopefully. And then if it is none, then we can use our result for whatever we want, such as printing it. Otherwise, we have to deal with it there. So, I mean, I'm not a fan of this. Admittedly, an easier way for something as simple as this might have been to use a Boolean. So if we just have bool divide, I mean, this is pretty black and white. Either the division worked or it didn't. In more complicated examples, which we will get into later in this video, you might have something like reading a file. Reading a file might go wrong for a number of different reasons. Maybe the file doesn't exist. Maybe the buffer you've provided to read the file is too small. Maybe the file is already open for reading and you can't obtain a lock on it. Maybe you don't have access to read that particular file. There are so many things that could go wrong there that obviously returning a simple Boolean doesn't cut it. But in this example, for the simple things in life, we can probably just return a Boolean. So if this is the case, then we can return false. Otherwise, let's just output our out result and return true. That does clean up the code a little bit because we don't have to do all of this enum checking. We can just simply put this into the if block itself, and then we have the result to deal with. Again, this works great in very, very simple cases, aside from, you know, the fact that we have this result here. But to be honest, this is probably the best thing we have built into C++ without using expected. So now that we have expected, let's rewrite this to use expected and then see if we like it better. So instead of returning a Boolean, we're going to return an expected object of either an integer, or in this case, we can just stick to our Boolean. Now, the best thing about this probably already is that we don't need this out result. That gets removed because the result is actually in the object we're returning. So if b is 0, then we can return unexpected, and of course it's going to be of this type. Otherwise, we just simply return this. And that's it. We don't need to wrap it in an expected. There's an implicit constructor for us. So then over here in the calling code, this changes a little bit. You store the result up here, usually as an auto object. The type is this, but because this is kind of long, usually we would just use auto. This is gone, which is great. Keeps our function really clean looking. And then we can simply check to see if the result is valid or not, if we have a result. There is also a has value function, but that is what this operator bool does for us. And then to use it, we use like this dereference kind of operator to get the value, or we can, of course, use value. Now, in this case, we actually don't care about the error value because we are just storing a bool, and that bool kind of reflects whether or not this is unexpected or expected, which is what this bool operator in the expected object itself actually does for us. So the data here is meaningless. Like, we probably wouldn't actually want to retrieve error because in this case, we know error is going to be false. False is the only possible error value that we return. So we can just assume that it's false, but this is how you would retrieve error. Now note that retrieving value and retrieving error is not valid. You can't call these functions. They will throw exceptions if result is not valid and you call value, or result is valid and you call error. So basically, you need to check what this is first before you can call value or use the dereference operator, and before you call .error. Now, how is this different than if we had just returned two values? So let's say we had a struct, divide, return result, which already you've lost me at this, but anyway, let's bear with it. So we have either our result or a boolean. Well, this actually would not be any different in this case. So what we could do is not care about setting result, but instead just return something like 0 and false. Otherwise, we could return the division and true. If you get a little bit clever with this and you return a bool operator, which simply returns a, then this actually becomes somewhat reasonable. You have your result, you can check result like this, and then you simply access the result. And again, if you wanted that same functionality, you could also have int operator this thing, and then have it return result. And then check this out. We have the same exact functionality, except obviously instead of .error, I mean, obviously you could implement the .error function and just return a, but we basically have the same functionality. Now, the reason why is because this just stores an int and a bool, both of them in memory. 4 bytes plus an additional byte. We have 5 bytes effectively of this packed struct data that we are actually storing. The same as if we would have used expected, because remember, expected also stores that additional bool of whether or not we have value. But what if we wanted to store something a little bit more complex, such as a string for our error value? Well, in this case, we're actually storing an integer and then a string. So we're storing more data than we need to. So what if we use a union? Well, you can probably see where we're going with this. We'll use a union and then we'll have to know, is it result or is it a? So has value, and we've basically just written the expected class. So yes, this is what it does. Except obviously it's a template and it's not hard-coded to be these two particular types. It can be any type. So hopefully this gives you a deeper understanding as to what expected actually is and how it works. Let's go back to int and string. I'll return this divide by 0 as an unexpected result, and we can get rid of this and return just the result. By the way, if you want to return this with our other struct that we made, you could of course add a constructor that just takes in this parameter, and as long as you don't mark it explicit, then this code will also compile. Okay, so the expected class goes a little bit deeper than this, but I think this simple use case is probably going to be something that most of you will use most of the time. If we have a look at some of the more advanced functions in there, the most interesting things that you can actually do with this is chain multiple expected functions together. So if we wanted to divide 10 by 2, and then depending on the result, potentially do another division or run something else, then once we do this, we can actually use this and then function. I'll drop it down here so it's a little bit cleaner. This takes in a lambda, which takes in the result of this previous function, and specifically the true result, the successful result. So if we have our division result and then we want to, for example, divide again, now and then, note that this lambda has to actually return another expected function. There's another function called transform that doesn't, but this one does. So let's say, for example, we then take the result and we divide it by 2 again. Maybe I'll pick something like 12 and 3. So that'll give us 4, and then we'll divide by 2, so we should get 2. So I'll return this, and you can of course keep chaining them. But what happens if the expected function fails? What happens if we get an unexpected result? Well, that's where or else comes in. So, and then is what we do if it's successful, or else is what we do if it fails. And these errors will propagate, meaning that if this one fails, we will land in here. And if this one fails, then we will also land in here. So in this case, we are of course going to get that error, which I can take in as const reference here. So we have our error, and then let's go ahead and just print it in this case. Maybe I'll drop this down here. We'll go ahead and print this, and this also should return an expected. So what we'll do is we'll go ahead and just create this expected object. However, I'm just going to set it to 0. So this is basically going to be our fallback value. So if these divisions fail, let's just return 0, and then we'll wrap up this lambda. So now we are actually building some kind of logic, some kind of code flow in a very functional style. We're trying to divide 12 by 3. If that succeeds, we are then dividing the result of that, which should be 4, by 2 again. If either of them fail, we are printing the error and returning 0, which means that at this stage, we will always get a result. We're not going to get an error at this stage because we have this fallback value, and that result should be 0. So let's go ahead and print that. If we run this code, then the result is going to be 2, because obviously all of these succeed. But if I change one of these to 0, then we're going to get this divide by 0, but we're also going to get a valid result of 0. And then of course, if this this one is fine, but this one is invalid and fails, then we're going to get the exact same result. We'll just get a divide by 0 error and our fallback value like that. You can, of course, omit this and just not have an or else, which means that you can handle it at the actual calling site. I mean, this is also the calling site, but you can handle it later just via a simple if statement in this case. But this kind of chaining functionality can be really useful if you want to avoid all of these if statements, because you can imagine that if we wanted to do something like this and just express it as if statements, which we obviously could do, we would have to do something like this. So we're just dividing here. Then if the result succeeds, we're going to want to do another division, which is this one over here. And then if that one succeeds, then, you know, we can print the result, for example, making sure it's result 2. You can see how as we keep going more levels deep into this, we're just going to end up creating this massive if statement nest. And then what about the else statements if they fail at any point, right? I mean, honestly, at this rate, you almost would rather use go-tos to actually get to that or else condition, because otherwise you're going to have to somehow break out of all of these nested if statements just to get to the point where it says divide by 0 error or handles your error condition, which is not good compared to this, where you simply have, you know, as many of these as you want, followed by a single place that actually handles your what happens if it fails condition. So this is another really, really strong use case, I would say, for this whole expected functionality. And if you utilize this properly, then I think there's going to be a huge improvement to the code flow of your error handling. Now, speaking of utilizing this properly, strings are not something that I would realistically probably return. You know, they're great for like little prototype functions or just testing stuff out like I'm showing you. But generally, the power of this is that you can return much more than a string. Specifically, you could return any type. I mean, I would be careful to make sure that that type, for example, doesn't allocate memory and is trivially copyable. You don't want to like have this huge thing necessarily, especially if you care about performance, obviously, but you could have something that has much more information than simply this. Now, I think it's about time that we ditch this simple example and instead let's look at how we might use expected in the context of trying to read a file, for example. Okay, so I got ChatGPT to generate a fairly comprehensive and thorough read file function which uses expected. I did have to clean it up a little bit, admittedly, but to be honest, not bad. Not bad. So this pretty much handles every possible state. So first and foremost, you can see we are returning two things. We're returning either a vector of chars or a file error. Now, file error is a struct that has 3 different variables here: a file error code, the path of the file that is the error, and a string message. It's also got this friend output operator, which I guess we don't really use cout anymore, but you can see it's got this operator here that just converts this file error, which definitely doesn't need to be taken in as a const reference. But anyway, it takes in this file error enum class here and just outputs a string. So it's kind of like a toString function for file error to just convert this enum to a string so that you can like print it. So this, I would say, is a fairly good example of the kind of error type you can actually return. It doesn't have to just be a simple error code. It could be an entire struct of data that will definitely help you actually handle your errors properly. Like, for example, the fact that this returns a path is kind of important, because if we go down to the calling code, say, for example, I had a bunch of these like, and then blah, 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 and then at the end of them, I had an or else. Now remember, or else is going to take in that error struct, right? But this or else kind of catches any of the and thens as well as the original read file that might happen. So we might not really be aware of which one of these failed. But if you have information such as that inside your error type, then obviously you can handle that appropriately. Now, going through the way that this actually works is pretty simple, as you might imagine. If, for example, the file just simply doesn't exist, then we can make an unexpected object here that has our error type in here. So we're creating an instance of that struct with file not found as the error code, the path, obviously, of the file. That happens for all of these. And then in this case, we're actually outputting this message that comes from these file system functions, this error code, which is like a platform specific error code of what actually went wrong for potential further diagnostics, which could be very useful. If it's just not a file, or there's a read failure, or the file's even too large, it defines like this 100 megabyte max asset file size, which of course is arbitrary. That's just something that we might have inside our asset system for whatever reason. Then it's just too big for asset loader is what it decides to print here. Otherwise, it will open it as a binary file here. We might not be able to, so we might get a permission denied, in which case we'll respond to that. And then finally, we'll try and read it. But then if there's a read failure, then we also return our unexpected. Otherwise, we simply return that vector, which is our buffer over here. Now, obviously from the calling point of view, if we have the result successfully, we're all good. But if we don't, then we can just call .error, and then on that error we can check the code, we can print the message, we can see which file failed. In this case we're only reading one, so it's obviously this one, but you get the point. And remember, because we have all of those other functions here, we can kind of get rid of these if statements if you so choose. So for example, if we read the file and then we want to do something with it, then in this case we could use the transform function. It'll take in that data, and then it might actually pass on that data to our actual asset loading system, and in this case we could just return the data because we don't really care about it, and we would get that in the original object. However, if it fails, we could of course print that error or handle it however we like. At this point, you may be slightly confused as to what the difference between transform and the and then function is. Well, it's pretty simple. And then has to return another expected object. Technically, they actually both return expected objects. So the clearest I can make the difference is that and then can potentially also fail using that expected system, meaning that it's perfect for if you want to, say, run this function if that result succeeds, but this can fail. All of the and thens that you have in your chain can fail, and if they do fail, then you wind up in or else. However, transform is used for things that cannot fail, because you can see I'm not calling that expected function again, I'm actually just returning this part of the expected object, right? The success condition. I'm not returning this error or anything. I'm just doing something with that result potentially and returning just that first part of it. Whereas with and then, I'm doing something that might also fail again, and I want to wind up in this or else. So in this scenario, transform makes sense because I'm not calling a function that returns expected again. I'm not doing something that might fail. I'm simply passing like the data on, and that's it. Whereas if I wanted to do something else, such as for example, parse that data, and then maybe that returns the expected result or an error code, and then I want to wind up in here. If I had wanted to chain together multiple expected calls here and then handle any of them failing inside this or else function, then that's when I would use and then. So hopefully you guys enjoyed this overview of expected in C++ 23. Let me know what you think in the comment section below. I personally think this is actually a really, really good addition to C++, and something that honestly, you know, if you have access to C++ 23 and you are in fact using that, which, you know, if you're just working on your own project, especially if you're starting a new project, you should be using C++ 23, then I would strongly recommend that you use something like this going forward. Let me know what you guys want me to cover next in the comment section below, and I will see you guys next time. Goodbye.